Graphing linear relationship. So what we've looked at now with the Cartesian plane is being able to graph something. And if we plot a whole bunch of points, we want to figure out what the relationship is. Now when graphing, we looked at graphing or plotting points on a Cartesian plane, which we always label with X and Y. Right? We always want to show which is X, which is Y. Okay, so make sure you know you plot it correctly, that you never plot the X incorrectly with the Y. Now, sometimes you might look at a graph that does not deal with any negatives, where every value is only positive. So remember, as we said, right? This part of the X is positive, this is negative. This part of Y is positive, this part is negative. So if we're dealing with a graph that deals with only positive values, we are only going to show that part of the Cartesian plane. Where this will be X, let's say, this will be Y. Sometimes they will not be as X and Y, but if you're graphing it, right, we might have things like time, and we might have stuff like money earned, let's say, but they still represent your X and Y. Okay, so let's look at the first sample problem. The following table of values shows the earnings based on time worked in hours. Graph the relationship and what are the earnings for 5 hours and for 10 hours. So now we have the following. We have a table of values which only has 4 sets of points. Now, when you have a table of values like this, right? We looked at in Cartesian plane coordinates. Now, if we look at these numbers, we have a 2 and a 20. So what does the 2 represent? Yes, it represents time worked, but on the graph, what would it be? The X. The earnings, $20 would represent, right? The Y. So in other words, whenever you see a table of values, right, you're really looking at coordinates. 3, 30, 6, 60, 9, 90. And here, of course, the 2 and 20. Let me just erase. So, in other words, the first value that we see in our table of values will be our X. The second will be our Y. Okay. So now, this will make things a little bit simpler, because if we're looking at this table of values and we're thinking, well, which one am I going to put? Right, here's my y-axis. Right? Here is my x-axis. So where am I going to plot that if I didn't know that already? Right? So make sure you remember. So the first value in a table of values is your x. Your second will be your y. So let me get rid of this. Make things a little cleaner. Now, when we are labeling it, always when you have a graph, and ignore the fact that in your notes, some of your in your book, it might not include it. Always use a main title. Never use something like this graph or my graph. Right? So be a little bit specific as to what kind of information are we going to be plotting in this. We are referring to how much money is being earned per hour. So use that into the title. If you're plotting something about yourself, put your name into the title. So this could be your money earned per hour. So, main title. Next, label your x-axis. Now notice I labeled it time worked, and in brackets I put down hours. If I want, what axis is this? This is my x-axis, which I can now label as an h-axis to represent hours. Right? But it's still referred to as our x. Right? But notice here I put the units. Include that, right? How are we measuring, time? Hours, minutes, seconds, right? We might be plotting it in seconds or minutes. Now, on the y-axis are earnings, right? And notice in brackets the units for earnings, the dollar sign, right? We're referring to money, right? In dollars. Now, I label these things in blue here. independent variable, the very first set in the table of values, is referred to as the independent variable. Very important to know. Very common independent variable that you'll be plotting, time. So time will always be on the x-axis. Now, we have earnings is the dependent variable. We don't plot that. We don't write those in when we're graphing, right? We should know them because you might be asked, which is the dependent variable, which is the independent variable. Now, if you look at the two variables, money and hours worked, which depends on the other? Right? Think about it. How much money you make depends on what? So your earnings, right? Your earnings depends on what? Exactly. So how much you make, right? That's why it's the dependent variable, because it depends on how much time you're going to work, because that's what's going to change your earnings. Okay. So that's the independent variable, which means that your next one is your dependent variable. So now, we're going to plot these. But now we can't just plot them because we need to actually put in some point values for these points, right? So let me. So we know that this point here, where they meet, bless you, is right at 0. So let me start plotting my hours. So we've got, let's say, 1 here. So I'm going to put 2. That's 3. So here's 4. That's 5. So I'm going to put here 6. That's 7. So that's 8, 9, 10, 11. And 12. Notice here, I didn't put it in increments of 1. I did it in increments of 2. Anyone know why I might do that? Why? Okay, I could do that. But I could put them as 1, 2, 3 if I wanted to. Why might I not want to do that? Why might not? Maybe it'll take too long? What else? I might not have enough space. Right? So all of a sudden, all the numbers are going to kind of clump together. Okay? So, and also, I want to use this. Here's the grid. So let's say I gave you this much grid on a test paper. I do not want to see a little graph like this take up that much space. Why would I give you all this space, all this grid, if I want a graph that small? I would have cut it in that and make your grid that small. That's what I would provide for you. So if you're provided with this kind of a grid, try to use as much of it as possible when you are graphing. So now let's plot my my earnings. So we're not going to go same thing. We're not going to go by ones. We're going to go, here's my 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120. Now, I've gone beyond what I've got, right? Because again, I want to use my space. Right? Notice that not necessarily, look at one of the earnings that I've got. I've got the number 30. It is not written out. So always space out. Use a proper scale to show your X and your Y axes. So, let's plot now the points. We've got 2. We've got 2 and 20. So we find the 2-hour mark and we go up to the $20 mark. We look at the 3-hour mark and we go up to the $30 mark. We go to the 6-hour mark and we go to the $60 mark. We go to the 9-hour mark and we go up to the $90 mark. So I have 4 points. Right? If I look closely, do they connect? Yes, they will. So there it is connected. So I've connected it because now, question says, what are my earnings at the 5-hour mark and at the 10-hour mark? Are those 2 hours shown on my table of values? No, they're not. So I need a graph like this to be able to identify how much it would be. But I don't even need that. I could almost figure it out because at the 1-hour mark, how much money are they making? $10. So we know that per hour, we are increasing by how much? $10, right? So we're increasing by $10 every single time, right? Notice $10 for every 1 hour. So we're always increasing 10 for every 1. We're increasing, right? So notice how we can do that for at every single hour, and we'll notice. So when we do something like that, this is what we call a linear relationship. Right? This is a linear relationship because the increments from one point to the other will increase at the same spot. Every point, right? My next point, look at it. Even though I've not drawn it in, it's not in my table of values. It's gone up by 10 to 1. Okay, and you'll learn what this is called. This is called slope. You'll worry about this. We'll worry about this a little bit later. But when we have something like that, where the increments are always exactly the same, we have what we call a linear relationship. So, let's answer the question. At the 5-hour mark, how much money did we make? So we find the 5-hour mark, and we've made $50. At the 10-hour mark, right? We find 10, we move up, and we made $100. Okay. So pretty straightforward, right? So let's look at what happens next. So linear relationship. Two variables share a linear relationship if a graph of their data forms a straight line, which is exactly what we did with that last sample problem. So they form a straight line because the point from one point to the other is always increasing by at the same rate. Each point is increasing by $10 every single hour. So, a few things to recap. The independent variable is plotted on the x-axis. I should put quotations here. Right, so time, right? If you see time units, right, it's a very common independent variable. Right, so we plot it on this x-axis. The dependent variable plotted on the y-axis and is dependent on the independent variable. Right? So the money earned depends on how many hours you're going to work. Right? So that's where the dependency comes from. And finally, always label the x and y axes. Right? So we labeled the x with hours. We labeled the y with money, and then we always also have a main title. Okay. So don't just label it with H or dollars. Write down money earned, hours worked, and of course include the units. That's why I say include the units. Now, let's look at the following sample problems. State whether the graphs are linear or nonlinear. So, from a graph, we can almost figure out if something is linear or nonlinear. So let's look at A. Is it linear or nonlinear? Linear, right? Linear. Letter B. Non-linear. Notice how it curves, so it's not in a straight line. Letter C. Non-linear. Right? Even though there are parts that might be like a line, right? But there are curves in it, so it's not consistently a line all the way from beginning to end. Straight line. And letter D is so linear. Now, identifying linear relationships as follows. So now, how do I identify if something's linear? Right? From the graph to straight line. That's simple, just like we just saw. But now what if I don't give you the graph? And I just give you this table of values. What can I do now with this table of values? What can I do? If I had the time, what can I do? Oh, you're a step ahead. What can I do with this table of values? You're kind of answering my next question. Oh no, you're answering that question. What are you going to say? Graph it, right? We can graph it. That's how I can tell whether or not I'm going to have a linear relationship. So now to kind of go through with when some of you guys were trying to answer, we look for the pattern. Now, let's look at what we call the difference. So we're going to look at the difference from each point of x. So from 0 to 1, what is the difference? 1. From 1 to 2?
1.
From 2 to 3?
1.
From 3 to 4? 1. So the difference is all the same. Okay, along the x. Now, let's look at the y. From 3 to 6?
3.
From 6 to 9?
3.
From 9 to 12?
3.
From 12 to 15? 3. Now, this here, what we've done here with the y's especially, this is what we call the first difference. Now, with the first difference, if they are all the same, right? Same means, okay, so if the first difference is the same, then we have something called a linear relationship. That's simple. We know it's going to form a straight line. Because remember with the first example, what were they all increasing by when we were going up? By 10. And we were increasing to the right by 1. So for every hour, it was every 1 hour. We were increasing our money value, our money earned, by $10, right? Every single time. So we look at what we call the first difference. So, let's look at the following sample problems. I'm just going to give you these two, but you're not going to have any space to graph them. So you got to figure out the value. So let's look at the difference. From -2 to -1, ignore the sign. 1. -1 to 0. 1. 0 to 1. 1 to 2. 1. So far, so good. Now let's look at the y. From 4 to 1. From 1 to 0. From 0 to 1. 1. From 1 to 4. 3. So, is this linear or non-linear? Non-linear. Okay? Because the difference here is not the same. Okay, so this is what we call the first difference. So now, let's look at our next example here. From -2 to 1, these are all 1, right? So, from 5 to 10. 5. From 10 to 15. 15 to 20. 5. And 20 to 25. 5. So since they're all the same in the first difference, this is linear. Now, what if I decided to expand this question and I threw in one more point and I said here, 3 and 40. This would be now non-linear because of that one. So don't be fooled just because you're seeing, 5 and, right? But then there's that difference here of, what is this difference here from 25 to 40? 15. Right? So the minute we have one difference, one out of place that's not the same, we have something, now all of a sudden this is considered non-linear.